Okay, so hello, I'm Kamna Mishra from IIT Mandi, and I'm here as your TA guide. And if you have any problems regarding the sessions, you can ask me, and I'm going to solve you some examples which may help you in your courses and to understand this course in a better way. I'm gonna start right away, and people may join in between. Okay. So I'll present my screen and one of you just confirm me whether it is visible to you or not. Okay, so is my screen visible? And don't write it in message, just please. Okay. So this course is basically taken by the instructor Professor Somesh Kumar from IIT Kharagpur, and I'm Kamna Mishra from IIT Mumbai. So if you have any doubts, you can ask in between, and you can ask now also. And if you don't have any doubts, so then I'll start. Okay. So, so the first question we have here is that suppose the probabilities of an event. So the question here is that probability of n mutually independent events are P1, P2 up to Pn respectively. Then we want to find what is the probability that at least one of these events will occur. So I think we have solved a similar question like this in the last class. So is there anybody who remember how to solve the question like this? Or is there anybody who has joined the last class also? Last Tuesday? Okay, okay. So do you remember how to solve the questions like this? Where we want to find that probability that at least one of the event will occur. Okay, okay. So do you know that? Oh, you want to say the answer? No, no. Say if it will be wrong, I will correct it. Right? So okay. So do you know the difference between mutually independent and pairwise independent events? Anybody? Okay. So, like if we have two events, just two events, then we say directly independent, because in that case, like pairwise independent and mutually independent is same. But when we say like for more than two, like event, say n is greater than two. Okay, so let's just assume that we have three events A, B, and C. Okay, so now these events are pairwise independent. What does it mean by pair? So pair means we take two. Okay, so it will be PAB is PA into PB, right? PBC will be PB into PC, and PCA will be PC just into PA. So these are the conditions for pairwise independent. Now if we add one more condition, PABC is equal to PA into PB into PC, then it will be mutually independent. Okay, so if we have four terms, then we have these many. equations for mutually independent. For pairwise independent, we just take the pairs. Now here what is given here is that we want to find what is the probability that at least one of the event will occur. So whenever we have a question like this, at least one occur, then what do we do is that we try to find the 1 minus probability that no event occur, right? Because if there is no event occur and we subtract it from 1 minus, then we have that means it will be one event occur, two event occur, up to an event occur. So that we can write at least 1 by 1 minus no event occur. Now 1 minus no event occur means P1 does not occur, P2 does not occur, up to Pn does not occur. So the probability of independent events, this one is P1. So let's say we have the events A1, A2 up to An. So if A1 occur, the probability of occurring of event A1 is P1. So probability of occurring of not occurring of event A1 will be 1 minus P1. So for this it will be 1 minus P1. For this it will be 1 minus P2 and up to 1 minus Pn. And if we can multiply it because these are independent events. So we can just write 1 minus P1, 1 minus P2 up to 1 minus Pn. So this will be the answer. So, anybody has any doubt? Okay. If you don't reply, then I will consider it as no, that you don't have any doubt. Okay. So we have here second question. What is the second question is that some elements in a chemical laboratory are highly contaminated. A high amount of contamination in element is likely to exist with probability zero point 0.1. Okay. So the levels of contamination are evaluated on four randomly chosen elements. How likely is it that at least one of them has high level of contamination? So what we want to find here is at least one again. So now uh, what we have is that 1 minus the probability that at least one of them has a level of contamination is equal to probability that 1 minus probability that no element no element has this high level of contamination. Now to have contamination, the probability is zero point 0.1. So for first element it will be zero point 0.9, and we are choosing four elements. So for one having no contamination or less level of contamination will be zero point 0.9. Similarly for second, similarly for third and fourth. So we will have this. Can anybody solve this? What is zero point 0.9 to the power 4 or 1 minus zero point 0.9 to the power 4? Okay, so it is 0.6561, which will be 0.3439. Okay, is it okay? Actually, if you will just say, then it will be better for me because then I need to come back here and then check whether there is any message in chat or not. Okay. So next question what we have is that each of the coefficient A, B, C are determined by throwing a fair dice three times. Then what is the probability? This is so sensitive. Okay. What is the probability that system of linear equation a square x plus by is equal to c? Uh, this a, b, c are coming from fair dice three times by throwing a fair dice three times. And then we want to find what is the probability that the system of linear equation a square x plus by is equal to 0. And the second equation is bx plus cy is equal to 0 has a non-trivial solution. So the equations given here are a square x plus bx plus by is equal to 0 and bx plus cy is equal to 0. Now, to have non-trivial solution, what is the condition for this equation, or maybe the determinant we have found, we can find there to have non-trivial solution. Uh, is there anybody who know how to say that this will have non-trivial solution? These equations have non-trivial solution when, like if I say that I am denoting a determinant, let's say determinant of a by a square b, b and c, then what is the condition to have non-trivial solution? uh, okay. Just a minute, somebody's on my door, just a minute. Okay, yeah, sorry for the disturbance. Yeah. So you don't know, you want to guess? Okay. So to have a non-trivial solution, the determinant of A need to be equal to not equal to 0. Okay. And to have a trivial solution, that this determinant A equal to 0. So I thought it was a basic thing, but it's fine if you don't know. So what? Uh, what? What? Okay. Non-trivial. Okay. But you know the thing, right? Okay. Non-trivial means the solution is just not zero zero basically. So the determinant of A need to be equal to not zero. So we want to find this probability. So determinant of A not equal to zero. So it means A square C minus B square not equal to zero. So we want to find the probability of this. So probability when A square C minus B square not equal to 0. Let me add one page here. So we want to find that probability of A square minus B square C uh, is not equal to 0. What will it be? So what we do is that we will find what 1 minus probability 1 minus A square minus B square C is equal to 0. So if we remove the points at which the solution is zero, that means at which the solution is trivial, then we can subtract this with minus 1 minus, and then we have the probability for the non-trivial one. So what is given here is that A, B, C are determined by throwing a fair dice three times. So the A, B, and C will come from this 1, 2, 3, 4, 5, 6. Right now, what given here is that we want if we want to find the probability of this, we will see what are the sets are lying here. So A square is equal to B square C, right? So C will be equal to, is it? Okay, no, it's A square C minus B square. Sorry. It's A square C, A square C. So it will be A square C. So C will equal to B square minus A square. Okay. Now, since C is what? This is 1, 2, 3, 4, 5, 6. So C can be either 1 or 4, right? C cannot be 2 because B by A will never be equal to root 2. B by A will never be equal to root 3 or root 5 or root 6. So B by A, because B and A belongs to these numbers, B by A can be like 1 or 2. So its square will be 4. So the possibility for B by A square can be 1 or 4 only. Now, uh, when it will be 1 and when it will be 4, we want to find that. So, when A and B are same, that time C will be 1. When A and B are like 2 and 2, so up to when A and B are 6, 6, then it will be 1. Now, when C is equal to 4, that means B by A is equal to 2. So it will be A, if I say that I am writing it in form A by A, B, C, it will be 1, comma 2, comma 2, 4, comma 2, comma 2, and then 6, comma 3, comma 2. So this is the entire set for which the solutions will be trivial. So, is it clear, or do I need to explain it again? Okay, okay. So what we want to find is that we want to find all the points A and B and C where the solution is trivial. Okay. So we want to find all those points. We will see what are the points will lie in that set. Now, C, we have the condition here is A square C minus B square is equal to 0, which means A square C is equal to B square. So C is equal to B square upon A square, right? Now B square upon A square, B and A given, sorry, the values of B and A will come from 1, 2, 3, 4, 5, and 6, right? So B by A, now C is also from 1, 2, 3, 4, 5, 6. So you can check the condition if you want, but otherwise the C can be 1 or 4. Let's say C is 2, right? So when C is 2, that means B square by A square is equal to 2. That means B by A is equal to root 2, which is not possible. B by A will not be root 2 because B and A both are integers. Now, similarly, when C is equal to, let's say, 3, 5, or 6, then that time B by A is root 2, root 3, root 5, and root 6, right? Now B by A cannot be in the form of irrational numbers. Why? Because b and a are coming from this, so b by a will be a rational form, right? Is it clear up to this? Okay. So the values of C we have is 1 comma 4. Okay. C we have 1 comma 4. Now when the C will be 1, when will it happen? When A and B are equal. C is equal to 1, that means B square upon A square is equal to 1. That means B is equal to A. Now plus minus will not come because the numbers are coming from 1, 2, 3, 4, 5, 6. So C will be 1 when B equal to A. So 1 comma 1, and this is C 1. So when A and B are 2, then C will be 1, up to when A and B are 6, then it will be 1. Next, so we have all the sets when C is equal to 1. Now when C is equal to 4, b square upon a square, that means b upon a is equal to 2. Now b upon a will be 2 when b is equal to 2a, simply. So a is 1, b is 2, and then, sorry, when a is 2, this is 4, and when a is 3, it will be 6, and when a is 4, b will be 8, and this will not come in set. So all the sets we have here is that 1 comma 1 comma 1, 2 comma 2, up to 6 comma 6 comma 1. And then when c is equal to 4, b by a is equal to 2. So for that we have 1 comma 2 comma 2, 2 comma 4 comma 2, and 3 comma 6 comma 2. Is it okay now? Okay. Okay. It's still in, yeah, yeah. Okay. Okay. Let me say it in this way. C can be 1, 2, 3, 4, 5, and 6, right? So C is equal to 1 comma 4 we have taken, because when C is equal to 2, let's say C is equal to 2, then that means B square by A square is equal to 2, right? Then B by A will be root 2. Now B by A will be root 2 means B is equal to A root 2. Now, if we have A is equal to like 1, then what is B? B will be root 2. Root 2 is not here, so it cannot be in the set. Now, A is equal to 2, B will be 2 root 2. ऐसे 3 root 2 and all. So, whenever we have A, C is equal to 2, that means B by A is equal to root 2. It means the values when we divide b by a needs to come as root 2, which is not possible because b and a both are integer. So their division cannot be a irrational number, right? Right. Okay. So these are the sets we have. Now if you count it, it will be like, I think, 6 for this, and then uh, 6 3 9. So total we have 9 sets, and the total number of sets we will have is that we can choose 1 2 3 4 5 6. So for this 6, for this 6, for this 6. So ultimately we will have this probability of trivial ones. Okay, I'm writing something. Oh, it's again. Am I audible to you? Okay, but my laptop is hang, I think. Do you know any shortcut key? Okay, so I will just uh, restart it, and then just I'll add it in 5 minutes. Okay, within 5 minutes. Control R. Oh, it's not working. Control R. I don't know why it happens all the time. Okay, I'll just come add. I'll just join in 2 minutes. Until then, you can solve this question. Like probability of trivial one will be 9 by 6 into 6 into 6. So it will be 1 minus 9 by 6 into 6 into 6. Okay. Okay. Is it visible? Okay. So what we have is that 1 minus 9 by 6 times 6 times 6. So it will be 2, 2, 4. And it will be 1 minus 1 upon 24. So it will be 23 upon 24. Probability for non-trivial. Right? No doubts, right? Okay. So we have this question, we have given here is that an is 0 to 1 minus 1 upon n, and bn is 0 comma 1 plus 1 upon n, and we want to find limit n tends to infinity an and limit n tends to infinity bn. Okay, so uh, do you want to do any kind of guess, like will it be same or will it be different? Options. Okay. And how to solve this? Okay. Let's just say we have an is that 0, 1 minus 1 upon n, right? So what we have is that 0, and we have 1, and an is that 1 minus 1 upon n. So when it will be n will be 1, it will be here 0, and when n is equal to 2, it will be somewhere here, sorry, 1 somewhere here, and then 1 by 3 it will be somewhere here, and this and this and this. So what happens is that 1 will never be reached. Okay, 1 will never come. So 1 minus 1 upon n. So what we will have here is 0 up to 1. However, when we have bn, it will be 0, 1, and 1 plus 1 upon n means 1 plus 1 by 2. That means either 3 by 2 or somewhere like this. So when you take the limit n tends to infinity, then 1 will be in that point. But here 1 will not be in that point. Okay. So its answer will be C. Okay. Okay. So now we want to find that which of the following is not a valid CDF. Now, what are the conditions for valid CDF? Or is there any specific condition which we can use here to check whether this is valid CDF or not? What is that? Yeah. So, non-decreasing function, firstly we can check. And if you just want to discard, you can check it by right hand continuous too. So, uh, I think you can try this question, and then if you will not get the answer, then I will say. And there can be more than one answers. Like I don't know exactly. Okay, so we will do it together, right? So let's say for this we have uh, fx is that it is 0 when x less than 0, x when 0, x and 1 by 2, and 1 is when x greater than 1 by 2. So at 1 by 2, what we can see that at 1 by 2, uh, we have situation like this, and then this. So this, sorry, this, and then we have this. So at this point, 1 by 2, right? It is x, that means x is 1 by 2, and at greater than 1 by 2, it is 1. So what we know is that it needs to be right hand continuous, and it is not right hand continuous. So it will not be CDF, so it will come in answer. Now to check B, what we have is that at 1 by 2, it is 1, right? So its plot will be something like this and this, and at this point, this is 1 by 2, right? So at 1 by 2, it is right hand continuous. If we say less than 1 by 2, in between 0 to 1 by 2, this x is a continuous function, so it will be continuous. Less than 0, it is continuous, and then 0 greater than 0, it will be again continuous. So this is continuous everywhere, right hand continuous at each point. So fx will be a valid CDF, so it will not come in this answer. uh, Now let's just check for the third one. So third one also, like less than 3, it is x cube by 27, and when greater than or equal to 3, so x cube by 27, x cube by 27, this is a polynomial function, and all the polynomial function we know are continuous. Okay, so we have this like what to say property. We have the property that all the polynomials are continuous. So since all the polynomial are continuous, in this in between 0 to up to 3, this x cube by 27 is continuous, and at each point the fx will be right hand continuous, and when x greater than or equal to 3, it is 1, so it will also be right hand continuous. Now check for the last one. For the last one, what is this? Fx is equal to 0 when less than or equal to 0, and at greater than 0, it is 1 minus 1 e to the power minus x. So we also know that e to the power x is also a continuous function. Okay. So e to the power x is a continuous function. So what we have is e to the power minus x will also be a continuous function. So at 0, we need to check, that's it. So at 0, it will be 1 minus e to the power minus 0, and it will be 1 minus 1, which is 0. So at 0, fx is 0. So at 0 also, it is right hand continuous. So A is the only answer for this question. right? Is it okay? Next, we have a question is that in a certain colony, 50% of the families own a desktop computer, 25% a laptop, and 10% both desktop and laptop. So I told you in the last class, whenever we have the question like this, what we use is that we use the Venn diagram to solve this. So what we have is here is that this one is 10, this whole is 50, let's say, and this whole will be uh, 25, right? So now if a family is chosen randomly, then what is the probability that family owns a desktop or laptop? So let's just say this is point 0.5, this is point 0.10, this is 0.25, right? Owns a desktop or laptop, not both. What it means is that this area, this portion will not come. So we want to find whether this or this. So in this point 0.5 minus point 0.10, if we remove, then this portion only, like let's say this is A, this is B. So A minus A intersection B, it will be point 4, and for similarly for B we will find this portion only, it will be 0.25 minus point 0.10, which will be 0.15. Okay, so these are the families which have desktop not laptop, and these are the families which have laptop not desktop. So if we add these two, we will have the probability that a family owns a desktop or a laptop but not both. So it will be zero point 0.4 plus 0.15. So it will be 0.5. This will be the answer. Okay. Uh, Now, okay. Do you know Bayes theorem? Okay. So we will have the questions on the basis of Bayes theorem. Uh, so uh, you can mute your mic. There is some disturbance. Okay, thank you. Okay. What we have here is that we have box one and box two. Uh, this is given it that first box contains three silver spoons and three copper spoons. Second box contains five copper spoons and three silver spoons. Now assume that box 1 is likely to be chosen with the probability 2 by 3, and box 2 with the probability 1 by 3. What it means is that if we have two box, uh, then and we are choosing a box randomly, then there is a probability that there is a chance that box 1 we will choose two times and box 1 we will choose one time, right? So choosing of a box 1 is 2 by 3, and for it is 1 by 3. So what is given here is that a spoon is chosen at random from a box that has been randomly selected. So we have randomly selected a box firstly, and then we have randomly selected a spoon from it. So we want to find what is the probability that it is a silver spoon. So firstly, we have randomly selected a box. So let us say we have selected a box 1. Now to select the silver spoon from box 1, it will be 3 by 6, because 3 silver and in total it is 6. Now to select the second box, it is 1 by 3, and to choose the silver spoon from this box will be 3 by 8, right? So we will have this 3, and it will be 24. If we take 6 like this, it will be 2, 6, 4, 3, 12, plus 3, 9. So just you can solve it later, I think, right? So it will be 9 plus 24. So it is 11 by 24. So this will be the answer. Okay. So next question what we have is here is that it is known that 2.5 of the mobile phone chargers fail during the warranty period. So we have one warranty period, let's say for 1 year or 2 year whatsoever is given. So 2.5% of the mobile charges fail during that warranty periods. So the probability, let's say it will be 0.25, right? Now the failure percentage is 5.6 if they are wet during the entire period. Okay. So if we kept it dry, then it is 0.025, and if we kept it wet, then it will be 0.056. Now, if they are ever wet during the warranty period, right? So, if 90% of the charges are kept dry and 9% are kept during wet during the warranty period, what is the probability that phone charger fails during the warranty period? So, this is what we have when the chargers are dry, kept dry. So, 0.91, and this will be multiplied by 0.09. So this means that wet period, okay? So we are putting the chargers wet during this period, during this warranty periods, and charger got failed, and this is we are keeping it dry and keeping it dry, and then it got failed. So it got failed in these two conditions only, so its summation will be the answer. So you can just solve it. I think after solving this was the answer, I'm not sure, but this was the answer. Is it clear? Okay, now we have the question here is that we have two urns. So let's say this is urn 1, this is urn. Now in urn 1 we have two white, one black ball. In urn 2 we have one white and five. Now the question here is that one ball is transferred from first urn to second urn, and then we want to find the and then we have drawn a ball from the second urn. We want to find what is the probability that ball is white. So what can we do here is that we can either transfer the black ball in the urn to, and the second condition, second case can be we have transferred the white ball into the second urn. So we have case 1 here is that white ball is transferred. Case 2 will be black ball is black ball is transferred. So in case 1, what will happen is that if we have transferred white ball, then in earn 2 we will have now in earn 2 we will have 2 white balls and 5 black balls in first case, right? However, in second case, since black ball is transferred, we will have 1 white ball and 6 black. Is it clear? Okay. So now we have in earn 2, these are the cases. Either this may happen or this may happen. So the probability of drawing white ball from this second earn will be, so if we will draw the white ball from this earn, it will be 2 by 7, and if we will draw it from this earn, it will be 1 by 7. So it's coming as 3 by 7. Am I doing anything wrong? 6, and then it will be 7. 6, 2, this one by is transferred. Is transferred. 2 by 7, and then 1 by 7. Okay, I don't know. It is not matching to any thing. So, but this will be the answer. There may be any mistake. Do you think there is any mistake in calculation? Okay, so if no, then this will be the answer. 3 by 7. So, next question we have here is that suppose the 10% of men and 5% of the women are colorblind. So, the 10% of men are colorblind and 5% of women are colorblind. A person is chosen at random. He and she is found to be colorblind. Then, what is the probability that person is male? Assume that 60% of the male where it is male. Assume that male constitutes 60% of the population. So, for male, this 60% are male and 40% are female. So, the probability that person is color blind will be equal to probability of choosing a man into probability that that man is colorblind, right? Similarly, we have probability of choosing a woman into probability that woman is colorblind, right? So, it this probability will be probability of choosing a man, since 60% contributes to uh, sorry, corresponds to male population, so it will be zero point 0.6. And the color blindness for probability for the color blindness for male is zero point 0.10, so it will be zero point 0.1. For women it is zero point 0.4 population, and this one is zero point 0.05. So we'll have zero point 0.6 plus, sorry, zero point 0.06 plus zero point 0.02 will be zero point 0.08, right? Now we want to find is that, so up to this we have found that person is colorblind. Now we want to find the probability that person is male. So person is male given it is colorblind will be uh, this zero point 0.6 into zero point 0.1 divided by this zero point 0.08, so it will be 0.06 by zero point 0.08, which will be 3 upon 4. Is it clear? Is it clear, everyone? Okay. Okay. Uh, so next question that we have here is that the chance that a certain disease is diagnosed correctly is 60%. So certain disease is diagnosed correctly is 60%. Now the chance that patient will die under the treatment after correct diagnosis is 40%. So let's just take it as 60%, okay? And the person die after this correct diagnosis is 40%. That means does not die will be 60%. Right? Now either the diagnosis will be correct or not correct. So for not correct it is 40%. Now uh, the chance of death by wrong diagnosis is 70%. So this will be 30%. So what is this? This is correct diagnosis. This is not correct diagnosis. This is, and these are this, and this will be, right. So what is the probability that his and or her disease were diagnosed correctly? A person who had died, who has the disease died, what is the probability that his disease was diagnosed correctly? So what will be the probability? Like person dies, okay? So now the when will the person die? If the disease is diagnosed correctly and it dies, right? So it will be zero point 0.6 into zero point 0.4. Now the other way is that its disease is not diagnosed correctly and it dies. So it will be zero point 0.4 into 0.7. So this is the probability that a person dies. So it will be 0.24 plus 0.28, which will be 0.5. Now, what we want to find is that we have given that person who has had disease died. What is the probability that his or her disease was diagnosed correctly? So, probability that disease diagnosed correctly, given that the person who had deceased then will be equal to, so for correct diagnosis it is zero point 0.6 into zero point 0.4, so it will be zero point 0.6 into zero point 0.4 and divided by zero point 0.5, so it will be 0.24 divided by 0.52, so this will be 4 and then 30, 4, so 6 by 30. Okay. Okay. Okay, so I'm just taking 5 minutes break. You can go through all these questions and you can tell me if you have any issue. If if you have any doubts in like assignment solving, that also you can say. So no doubts, huh? Okay, so I will just start. So here given here is that each of n urns contain 4 white and 6 black balls, while another urn contains 6 white and 4 black balls. So what do we have here is that we have urns here. Okay. Now n number of urns contain 4 white and 6 black, right? And there is one urn which contains 6 white and 4 black balls. Now we are choosing an urn at random from this n plus 1 urn. So we have this n urn, this 1 urn. So total we have n plus 1 urns. What we are doing here is that we are choosing uh, two balls from this n plus 1 urn. We are firstly randomly choosing an urn from this n plus 1, and then we are choosing two balls from it, and both are black. So the probability that 6 white and 2 black balls remain in the chosen urn is 1 by 11. So the probability that this so probability that 6 white and 2 black ball remains. So can you tell me that which urn we have chosen so that we will remain with 6 white and 2 black balls? See, in these urns, what we have is that we have 4 white and 6 black balls. Okay. In the second, like in a separate one urn, we have 6 white and 4 black balls. At last, we have remained with 6 white and 2 black balls because we are choosing two black balls. So what it should be, like what urn we should have chosen there, so that we will remain with 6 white and 2 black balls, like this one or this one. You all are here, right? Okay. So what it should be? Okay, just see here we have four white and six black balls. Okay, so if we take two black, we can remain with four white and four black. Okay, but the given here is that six white and two black. So if we take two black from here, then we will remain with six white and two black. So the question itself is telling you that we have chosen there one sorry the second one earned, and this the probability of this is 1 by 11, and then we want to find the n. So firstly what we have is that we have the probability of drawing or taking two black balls, right? So if so now what we have is that these are n urns, this is one urn. So choosing these urns will be probability will be n upon n plus one, and choosing black ball from this will be 6 upon. Here it will be 1 upon n plus 1, and choosing black ball will be 4 upon, right? So it will be n plus 1 times 10, and it will be 6 n plus 4, right? Is it okay? So the probability that this urn has been chosen, like, or let's say second urn has been chosen to draw the second ball, so to draw two black balls, and given this condition, so it will be 4 upon n plus 1 times. Oh, okay. So there's a mistake. We are choosing two black balls, so it should be C2. So it will be C2. 10 C2 will be 10 times 9 by 2. So 9 5 45. And this will be 6 5 5 3 15 and plus 4 times 3 3 and then 6. Okay. So it will be 15 and it's 1 by 6. It will be 4 C2 divided by 10 C2 whole divided by 15 n plus 6 divided by n plus 1 times 45, and this is given here as 1 upon 11. So this will cancel out. What we will remain with, we will remain with 15 n plus 6 is equal to 1 upon 11. Now, now anybody solve this and tell me the answer. What will be n? Is this question clear to you, all of you? Okay, so you just please solve and tell me what is the value of n. Are you solving? It's not too tough calculation. It will be 3 upon, sorry, 2 upon 5n plus 2, which will be equal to 1 upon 11. So it will be 22 is equal to 5n plus 2. So 5n is equal to 20, n is equal to 40. Right? So 4 will be the answer. Now this is a little bit different question. Given here is that we have a bag of 100 coins. 99 are fair coins. Fair coins means getting a head. Probability of getting a head and probability of getting a tail is same, which is both is zero point 0.5. So what we have is there here is that we have 100 coins and 99 are fair coins and one is unfair. So the getting head or tail, its probability of 0.5, right? And one unfair is that probability of getting a head is 1 and probability of getting tail is 0. Just 1 minus 1, right? So sometimes if you just want, like, sometimes you may have this, but generally it does not happen that you have a coin with such probability, like head is 1 means, what it means is that both sides we have head, so that's why we are getting the probability of uh, head uh, is 1 and tail is 0. Now, what we are saying is that we are picking a coin randomly and flipping it 10 times, and then we want to find, and we are getting the head every single time. Then we want to find what is the probability that it came from unfair coin. Okay. So, firstly, we will find the probability that we are getting head every single time. So, probability of getting head in all 10 flips. What it will be? You have done so many questions, right? Till now for the base theorem. So what it will be? Probability of getting head in all 10 flips. Let's just say we are selecting one coin. So firstly we have the probability of selecting fair coin, and then we have the probability of selecting unfair. So the probability of selecting the fair coin will be 0.99, and the probability of selecting unfair coin will be 0.01. Now we have selected this firstly. Now let's say we have selected the coin from this fair coin. Okay, so we have selected it and now we are flipping it 10 times. So getting the head 10 times, its probability will be zero point 0.5. In the first time it will be zero point 0.5, second time it will be zero point 0.5, third time it will be zero point 0.5, and so on. Because when you toss a coin and you get head or tail, right? Let's say you have got head this time. Then next time it is independent of the event whether you have gotten this head or tail in the first time. So in the first flip, if you have the probability of getting head is zero point 0.5, then in the second flip it will remain as zero point 0.5. So in the third, in the fourth, in every flip, the get probability of getting head will be zero point 0.5. So it will be zero point 0.5 to the power 10. So now selecting this fair coin, firstly we have selected a coin from this fair coins. It is 0.99 and the probability of getting head is zero point 0.5 to the power 10. Now selecting this unfair coin will be 0.01 and getting the head is zero point 0.1 to the power, sorry, 1 to the power n. So it will be 0.99 times zero point 0, so zero point 0.5 to the power 10 plus zero point 0.01. Is it clear? Okay. So now what is the probability that you picked from unfair coin will be, this will be on a numerator and this whole function will be in denominator, right? So probability of getting this, that you picked unfair coin will be 0.01 divided by this whole probability. Let's say P H, this P H, this will be the answer. So now we have this question as discrete random variable. So the discrete random variable have probability mass functions and the continuous random variable have probability density functions. Okay. So given here, we have given here is that there are x values with -2, -1 and so on, and the probability at each point or getting a point is given in the second row, and then we want to find the probability that mod x is greater than 1. So we want to find mod x is greater than, so you can do it in two ways. What it will be, firstly you can take the mod x greater than 1, which means x is greater than 1 plus x is less than -1, right? Or what you can do is that probability of mod x greater than 1, it will be probability 1 minus probability of x in between -2 plus 1, right? So you can do it in either way and you can even check that whether your answer is correct or not. So we will do firstly from this. So probability of mod x greater than 1 is equal to probability x greater than 1 plus probability x less than -1. So x greater than 1 we have this point, x less than -1 we have this point. So its probability will be 1 by 9 plus 1 by 9, which will be equal to 2 by 9, right? In the second one, what we have is here is that probability of mod x greater than 1. Let's just do it with this way also. It is 1 minus probability of x from -1 to 1. So for -1, this. So it will be 1 minus 2 by 9 plus 3 by 9 plus. So it will be 1 minus 3 to 5, 7 by 9. So it is also 9. So in either way you can solve this. Now we have given here is that a random variable x has the following mass functions. So we have given x as a random variable, its values are given and its probability is given, and we want to find the probability x less than 3. So Does anybody know how to approach this problem? Like, firstly, we want to find what is k. So, how do we find this k? Okay. So, what we have here is that probability of x, this, yeah, or let's say fx when we have x at this point. So, probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2, 3, and so on. Let's say probability of x is equal to 5, right? So it, it is equal to 1. So probability of x is equal to 0 is 0. For 1 it is 2k. For 2 it is 3k. 3 it is 2k square. 4k 9k square plus k is equal to. So this is the quadratic equation you can solve. So solve it. Like, try it. Solve it and tell me what is the value of k, like which value we should choose and which value we should reject. Like we will get the two values here as it is quadratic. Then what value we will choose as value of k. This is a basic equation. It should not take this much of time, I think. So what we have is k square is 11k square, and then k terms we have 2, 3, 5, 5, 4, 9, 9 plus 1. So we have 10k minus 1. So it will be 11k square plus 11k minus k. So 11k plus 1 minus this one. So we have 11k plus 1. 11k minus 1 and then k plus 1 is equal to 0. So k is equal to minus. Now which value we should take and which value we should reject here. Okay, but I have already solved it. Now I have just given you k as minus 1 and 1 by 11. And why? Because the probability cannot be negative. So probability cannot be negative, so we will take it as 1 by 11. Now we want to find the probability that x less than 3. So it 0 will not come, so it will be 2k plus 3k, 5k, and 3.3. Sorry, the x value as 3 will also not come. So this will equal to probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. So probability of x less than 3 will be equal to 2k plus 3k plus 0, which will be 5k. So it will be 5 by 11. So 5 by 11, what is its value? It is 0.4545. This 0.445 is given. You can write it as 0.4545. This will be the answer. Now we have here probability density function. So because the x uh, random variable we have here is that this is continuous. So the property, sorry, solution will not come. It will come as minus infinity to infinity. X is equal to x is equal to 1. So we will divide it as minus infinity to 0 x plus fx dx plus 0 to 1 fx dx plus 1 to infinity fx dx is equal to 1. Now this value given here is that 0 to 1 we have something in fx, otherwise it is 0. So this value and this value will be 0. So we will remain with 0 to 1 kx x plus 1 dx is equal to 1. So we will have k 0 to 1 x square plus x dx is equal to 1. Find k from here. This is, I think, simple integration. So you can do that. Have you guys submitted the assignments for week 1 and week 2? Okay, because week 2 cover. Okay. Because like your due date is 9th August, I think. So if you have any issue in the assignments, then you can ask me after due date. So once you can submit it, and then if you have any doubt, you can ask me in the next class. So you are solving this, right? Do you guys usually take this much time to solve this integration, this kind of integration? Yeah, yes, Priya. You have raised your hand. If you don't have any issue, then you can lower it too. Okay, 5 and 6. Priya, you have any issue? So K is 5 by 6. So now upper fx x will be 5 by 6 x x plus 1 for uh, x in between 0 to 1 and 0 otherwise. Right? Now we want to find the probability when x is in between 1 to 4. So it will be 1 to 4, 1 by 4, 1 by 2, 5 by 6, x, x plus 1, x. Right? So we will have 5 by 6, x square will be x cube upon 3, and this will be x square upon 2 and over 2. So firstly we will have 1 by 2, so it will be 1 by 8 minus it will be 1 by 4, 64, and plus 1 by 2, so this will be 1 by 4 minus 1 by 16. So it will be 5 by 6, 6 times. Multiplication times 25 by 192. Was that 5 by 6 or 6 by 5? K value. So K will be what? Um, it's K times 5 by 6. So K will be 6 by 5, right? Huh? So this will be 6 by 5. This will be 6 by 5. 6 by 5. This will be 6 by 5. So this will be 5. This will be 6. 3 times 18. And this will be 5 by 32. Right? So 5 by 32. So now what we have here is there's yeah, questions. Suppose that it is known that the number of items produced in a factory during a week. Uh, have you seen the lectures of week 3? Huh? No? Not yet. Okay. So, this is the question based on the lecture of week 3. So, we'll do it next. Firstly, we will do this question. So, what is given here is that out of 2m plus 1 tickets numbered consecutively, 3 tickets are drawn at random, and we want to find the probability that the numbers on the ticket are in arithmetic progression, right? So, what we have is that we have tickets numbered consecutively. So, we have, let's say, this, or it is not necessary that it is starting from 1. It may start from 10 and up to like the number can be different, but this is I'm writing as this is the tickets we have. Okay, and the numbers are consecutive, so you may write it as a plus 1 and then something like that. So, 3 tickets are drawn at random. We are drawing 3 tickets. So, 3 tickets drawn at random. We will have 2m plus 1 c 3. Right? This is the simple thing. Now, we want to find the probability that numbers on the tickets are arithmetic progression. So, we have A, B, C. 3 numbers, let's just say. So, what is the condition that these 3 numbers are in arithmetic progression? You know arithmetic progression, right? Yeah, that is right. Like arithmetic progression means we have the difference same between all the numbers, right? So let's say we have this A, B, and C. We have 3 numbers in arithmetic progression. Then what is the condition for that? I have just told you that difference is same, right? Like if we have 1, 2, and 3, difference is same. 1, 3, and 5, difference is same. 1, 4, 7, difference is same. So if we have A, B, and C, and the difference is same, what we can like do from here? Just think a little bit. Like maybe you just don't remember, but difference is same. What it means? Like write it as an equation, like A, B, C, and difference is same. Then what is the equation we can get from this uh, property? let's say. Okay, what is the difference between A and B? How do we find difference? It is like we subtract it, right? So what will be the difference? It will be B minus A, right? Right. So the condition we will have is B minus A, and the difference is same. So it will be C minus B. So the condition we have here is that 2B is equal to A plus C. Right? Remember, this was the property for the arithmetic progression. If we have any three numbers, then A plus C is equal to 2B. Right? Yeah. So now 2B, that means this 2B is an even number. So when 2B is an even number, A and C needs to be either odds or even, right? So if A and C are both odd, or A and C are both even, right? This is clear. So A comma C needs to be both odd, or A comma C needs to be both even, right? Now we have 2m plus 1 tickets, and these numbers are consecutively written. So either it is the possibility that we have m odds and m plus 1 even numbers, or vice versa, right? So either we can have m odds n plus 1 even, or we can have m plus 1 odd and m even numbers. Let's say we are starting from 2 3. So I think if you start from 1, then it will be m plus 1 even, and m plus 1 odd, and then m even terms. And if you start from 2, then you will end up having m plus 1 even terms and m odd terms. So in any case, what we have is that A and C both come from odd, or A and C both come from even. So we will have m odds, m plus 1 even. So we are choosing two numbers from odd or two numbers from even. So if we choose this, or if we choose this, then it will satisfy the condition of arithmetic progression. So now you can solve this value. So below part you will have 2m plus 1, 2m, 2m minus 1, and then 2 factorial will be cancelled out. Here you will have m minus 1 plus m plus 1 times. So ultimately you will have m square minus m plus m square plus m. So you will have, uh, okay, here is 2 factorial, here is 3 factorial, here is, just add one more slide here. divided by 2m plus 1 c3. So it will be 2m plus 1, 2m, 2m minus 1 divided by 3 factorial. It will be m 1 minus 1 divided by 2 factorial plus m plus 1 times m divided by 2 factorial. Right? So you will have 2m plus 1, 2m, 2m minus 1, and here 3, and you will have m square minus m plus m square plus so m will be cancelled out. So you will have 3 into 2m square divided by this value. So in the answer you will have 3m divided by 4m square minus 1. This 2m will be cancelled out by 2m. So you will remain with 3m divided by 4m square minus 1. So this will be the answer. Is it clear? Is it clear, everyone? Okay. So this is the question I have taken from week 3. Week 3, so it has two, it will use two property basically. So first one is that Markov inequality and second one is that Chebyshev inequality. So I will first rewrite what are these properties and then we will solve this question. Markov's inequality. So what does it say? It is that let x be any random variable you have, okay, and g be any non-negative function or decreasing function. G be non-negative even and non-decreasing function of mod x, then probability of mod x greater than or equal to k is expectation of gx by g of k. So next we have is that Chebyshev's inequality, which says is that if you have, let's say, any x is random variable and we have its mean as mu and variance as sigma square, then for any k greater than or equal to 0, this probability of x minus mu less than k is greater than or equal to 1 minus sigma square upon k square. So basically what it means is that we have x is any random variable, we have x as a random variable, okay. Now mu is mean. So uh, what does it mean? So it means average, okay. So simply if I will try to describe it by using normal distribution, let's, okay, we have normal distribution, we have mean, mu, and then we have variance sigma square. So standard deviation will be minus sigma. So what this property tells us, this property that x minus mu probability that x minus mu less than k is greater than or equal to 1 minus sigma square upon k square, which means x we have any value, okay, mu we have mean. So the probability that the values lies in between, so we can write it as x lies in between uh, k minus mu to k plus mu, no sorry, minus k plus mu minus k to k. It will be minus k to k. So minus k plus mu to k plus mu. So the probability that any value lies between minus k plus mu to k plus mu, that means the probability that any value lies between here. Let's say k is here. So this probability will be greater than or equal to 1 minus sigma square upon k square. Means we want to find the numbers, like if you have, say, on an average the life of a bulb is like 10, let's say 100 days. So what is the probability that the light of this sorry the lifetime of this bulb will be, let's say 100 days, lifetime of a bulb. So what is the probability that lifetime will be in between 90 to 110 days? So what we can do is, here we have given mean as 100 and let's say some standard deviation as 4. So we can take x minus mu less than k and we can take k value as 10. Okay. So what we have is, here is that the probability that lifetime of this bulb will be in between these days, we can use Chebyshev inequality in that case. Okay, so let's just move to the question. So, firstly, the question is here is that mean we have given as 50, and we have a question is that what can we say about the probability that this week's production will exceed 75? So, there is a factory which produces generally 50 number of items because mean is average. So, generally it produces 50. So, what is the probability that week's production will exceed 75? So, it will be probability of x greater than 75. So, what it is expectation of x divided by this 75. So, it will be 50 upon 75, which will be 2 by 3. Now, next question what we have here is that we have given variance as 25. So, sigma square given here as 25. And what can we say that the week's production will be in between 40 to 60. Now, 40 to 60 means mean we have given here as 50. So, what we can take as k if we want to find the production between 40 to 60. Let's just say that uh, we have x minus mu less than k. Okay. So probability x minus mean is 50 and less than k. And we want x between 40 to 60. So what we can take as k. Okay, so we will take k as 10. What will happen when we take k as 10? It will be minus 10 plus 50, so it will be 40, and then x 60. So this we will have between 40 to 60. Maybe this is not clear too much because you have not gone through the lectures yet, but once you will go through, it will be understood. Okay. So now we will take k as 10. Okay. So now we know that probability that x minus mu less than k is greater than 1 minus sigma square by k square. So it will be 1 minus sigma square by k square. Right? So 1 minus sigma square is 25 and k square here is 100. So what it will be? It will be 1 minus 1 upon 4. So it will be 3. So 3 upon 4 will be the answer. Yeah, you need to find that k because like you will have the values like here given 50 to 60. So it may happen that you will have given the value of k, but like it is like theoretical question. Okay, so they don't say that take the value of k is like this. You need to read the question and then you need to understand what value of k will work here. It is nothing but just simply subtract this mean from any of these value. So if you have 40 or 60, you can take like you have mean given as 50, so you will subtract, like if you are taking lower value, then subtract mean from this, sorry, subtract this from mean, so it will be 50 minus 40, it will be 10. Or if you are taking the higher value, then subtract the mean from that value, so it will be 60 minus 50, it will be 10. So in any case the value will be same, so that value will be k. Okay. And now if we have like in place of less than k we have greater than k. Let's say you have probability of x minus mu greater than k, then any guess what it should be? Like there we have one. No, no. Here when you are taking less than k, it is 1 minus sigma square by k square. So when you take greater than k, what you do is that this you will subtract this, right? Like when you have probability of x less than 1, what you do is that 1 minus probability of x greater than 1. So in that condition, when here you have probability of x minus mu less than k is greater than or equal to 1 minus sigma square by k square. Here you have probability x minus q mu greater than k, then it will be less than sigma square by k square. Okay. Okay, so this is it. If you have any doubts, you can ask. Hmm. Uh, Actually, I don't refer any particular book. I just go through some questions randomly, sometimes from net and sometimes from the assignments I have solved earlier. So I'm not referring any kind of book here. But if you just want to go through the basics and you want to solve the questions, like if you have problem in solving questions and you think that you need practice, you can go through Gupta and Kapoor. There's a book, Probability and Statistics, Gupta and Kapoor, and there are so many solved examples, so you can go through that. Otherwise, sir, may have given. I think sir has given the reference books for this course, so you can go through those books also. Okay. Okay. So okay. Okay. So it's okay, everyone. You can leave. Thank you for joining the class.